Okay, welcome back to the last video of this section for 1.2. Again, we're talking about domain and range and how to write down these intervals either in interval notation or inequality notation or graphically. And just as a review, if you look at, I think we're on page 3 of the notes here, we have an open circle here and a closed circle here, meaning so from 5 to 10, we need to find the ability to write the solution set in interval notation. And if you're going to do that, let me come over here real quick and notice soft bracket means not included. And soft bracket not included, which is here, but not included also meaning open circle, if you remember. And included, I apologize if I'm using those interchangeably. Notice it's a hard bracket here, so that's included. So this is not included. And you keep hearing the same thing over and over and over. And again, that's represented in inequality notation with no equal sign here and an equal sign on the back end. So not included is an open circle, no equal sign, soft bracket. Included is a filled in circle, equal sign, and a hard bracket. Try to keep that in mind as you go forward here. And maybe we'll just review a couple of these things on the right side. In interval notation, the next example, let's take a look at the second one here, right? Notice I'm included at 5 and my solution set goes to 10, open circle, so 10 is not included. How you would write that? Hard bracket, lowest value to biggest value, soft bracket because 10 is not included. If I were going to do this one underneath it, the third one, just the interval notation, notice the open circle on both boundary values. Open circle means soft bracket from 5 to 10. And really, the only difference in these two answers is that 5 is included here, not included in the bottom one. Hopefully you're getting that. Now, as you go forward, I should say that there's yet another way, and you won't see me use this too often, but just in case you see it in the future, it's called set builder notation, right underneath my squiggly line there. And all it means is that there's a little h here in front, which means the set of all h. This vertical line means such that. So if you wanted to write set builder notation for all the other two examples we just did, you could say the set of all h such that, see how I'm writing it? So rewind that over and over until you got it. It's the set of all h such that, so such that is that vertical line, and then you just copy over the inequality such that 5 is less than or equal to h, which is less than 10. That's set builder notation, and you might see it sometime in the future. If I ask you for set builder notation for the next example, you would say the set of all h, here's such that again, vertical line. A lot of times in the math world, the mathematicians that were so brilliant before us uh, just came up with abbreviations for everything so they can say a lot in a little amount of space. So again, the set of all h such that that vertical line, and then you can copy this interval notation. 5 is less than squiggly mark. At this point, pause the video, do the next two, and fill in all those 5 blanks there. Okay, maybe if you did it or if you're just still listening, what I like to do, and it really doesn't matter, I usually do the interval notation first. And notice I'm now on example 3 here, or the third star. If I wanted to go all the way this way to negative infinity, I have to start at the lowest, go to the highest, and because I have an open circle here, I have to make a parenthesis here. So that's how I would write that. Notice the inequality here. H is less than 10, and this is what it looks like in interval notation. But if you wanted to do it in set builder notation, the set of the set of all h such that, notice there's that vertical line, h is less than 10. The next one, the fourth example, we'll call it example 4 here. Everything bigger than 10, isn't it? Oh, excuse me. Yeah, well, yes. So that arrow goes on forever this way. So everything bigger than 10, notice I have a closed circle there. So closed circle means hard bracket, 10. And if you're going to go up to infinity, you just need to write that. Here's another quiz question. Hard bracket, soft bracket, if I'm going to infinity. Soft bracket, because hypothetically you can never get there. If I'm going to write set builder notation, h is greater than or equal to 10. Well, here we go. The set of all h such that h is greater. Now, the only other thing that happens quite often is a lot of times your number line will be all real numbers or go forever in both directions. And when that occurs, you can either say all real numbers, there's that R that I was talking about earlier, or in interval notation, negative infinity to positive infinity. And remember, the parentheses always have to be next to the infinities, and you're always going smallest to largest. Quiz for you, example 4, go for it. Do this example here and give me the inequality, set builder, and the interval notation. Turn the video on when you're done. Okay, if you're back, inequality-wise, the solution set here from 1 to 3, those points are included. So inequality, we're going to say 1 less than, I might run out of room on my pad here, but 1, let's call it, we used 3, and you got to make those both equal signs because the points are included. And also from 5, and I guess you can go, because this arrow is going forever this way to infinity, you can leave it as such. Again, no equal sign here because there's a circle, open circle. 5 is not included on that upper boundary set. And remember, if you're going to write it like that, you can say this, the solution is this, and 5 less than h. It's the solution for everything. Now in set builder notation, you just write the same thing. Set of all h such that, and then you just copy that inequality over 1 less than or equal to h less than or equal to 3, and those are all the possible solutions. And I probably shouldn't be using this word and. I think that's probably incorrect. You can say or. I apologize. And means something different, so I got to make sure to get my terminology just perfect. But so that's how you write it down like that. And if you're going to write it in interval notation, you can just write the two intervals, hard bracket 1, 2. That's from here. The other part, bigger than 5, is city, because this goes upward forever again. Again, if you have an or, what's called a union, you're going to put a u here. United with both. So the solution set is anything between 1 and 3 with those endpoints included. And on the right side, 5, just after 5. So 5.1 all the way up until infinity. That's how you do it on a number line. And the only thing left to really discuss is how you do this graphically. Now, if I were going to ask you from a picture, write the domain and range of this picture here. Notice in red, that's the domain. The domain is talking about the x's, and the range is talking about the y's. And I couldn't ever remember, and a lot of times you'll see me write it like this, the domain, dot, dot, and the range. So that's how I'll kind of begin my I don't know, depiction of whether I'm talking about the inputs or the outputs. But notice domain are the inputs, the range are all the outputs, And I couldn't remember which one was which. So a lot of times what I would say is D comes before R in the alphabet, X comes before Y. So it's kind of a stupid trick if you're stuck on talking about X and Y. D comes before R, X comes before Y. So when you're being asked about the domain of a function, what you can do as far as the answer is concerned is you can say, well, my domain are all the X values that are possible here. And what happens is my function starts, it looks at like to be -5. And notice the point is included. I'm being asked to do it in interval notation as well. So I start at -5 and all my x's go this way forever because this graph here goes down forever and it keeps going down and kind of this way at the same time. So even though it's gradual, it's still moving to the right. So that's why for the domain, you're seeing in red here, which I can do in red, this line here is going this way. So might as well even color code that. So the answer for the domain, in this case, the domain has to be from 5 to infinity. Be a soft bracket. Just hard to write on this thing. Now, in green, the range of this thing isn't talking about the x's, but remember it's talking about the y's. And my y is the highest value. Now here's the hard part. My highest value looks to be, well, 1, 2, 3, 4. It looks to be here at 5. Writing this should be -5. But the range, as far as the y values go, I max out at 5, but I go down forever to -infinity. Now that's just mainly due because this graph, that arrow means it continues on forever down and over to the right. Hard part, you have to write it smallest to biggest. So -infinity is actually the smallest thing here. So it's got to go first. Otherwise it's wrong. So I know it sucks. I had a hard time with that when I was first learning it, but -infinity all the way to the highest value up here, which is 5, included because it's a solid line right there, a solid dot, the points included. That's your answer for this problem. So remember, smallest, biggest. Don't forget that Easter egg. Steph Curry is still showing up. So when I ask you what's in the notes, what basketball player is in the notes, repeatedly you can say Steph Curry. So last problem, do it on your own. Give me the domain and range of that thing, and we'll do it in red and green, just like the last problems. Okay? Pause the video, come back in 1 second when you get the solutions. Okay, if you're back, notice this function, it's still a function, it passes your vertical line test. And for the domain, remember the domain is a set of all x's that work, or inputs. And you start at -3, but it's not included, so you should have a soft bracket from -3, and you're going to get larger all the way. If I plug in a -2, I get an answer. If I plug in -1, I get an answer. So definition-wise, the domain is the set of all the stuff that you can plug in that gives you something out, or the set of all inputs that yield an output. But my x's go all the way to 1, and then there's nothing over here where I have a function, meaning there's nothing in this space here where there are x values for my graph. So I cap out, I think, at 1, and the point is included here, closed circle. So that's it. That's my answer for my domain. Likewise, the range are the set of all the outputs, or the y's. Remember, those are the y's, or the outputs. This graph. And there are no y's up here. Remember, for y's, I'm looking up and down. For x's, I was looking left to right. So for my y values, there's nothing up here, and there's nothing down here. I only have y values from a maximum of 0. And look how I write it over here. That's my highest value. And my lowest y value, it gets -4. Oh, it can have the same value twice. It just never gets below -4. So the only difference or mistake I've just made in just talking is that, well, let's see if you can pick it out. -4, should that be included or not included? As far as the y value goes. And it's not an open circle, but it's filled in. So it means -4 can be used in my set of answers. So that's how you do that one. That's about it for this video. You can come down here. There's my toolkit again, and Steph Curry as well. And much about these lecture questions, but we'll assign these as labs or additional problems in the future. So if you want practice, they're always there to kind of work on, and you can either check in the math lab for the answers or you can ask. Okay, great job so far. That's the end of your second section. Fantastic. I'll see you for the next one.